Okay, so today we're going to be talking about how to do inverse trig derivatives. Now to start the lesson, I want to talk about what inverse trig derivatives are. So you probably know a couple of them, like arc sine x. So in a normal trig expression, like sine x equals y, your input value of x is an angle, and then that expression yields a ratio that you would later use. And then in an inverse trig expression, your input is the opposite. Your input is the ratio, and your output is the angle value in the trig expression that would give you that ratio. So these are inversely related. Now, a common mistake is to confuse inverse trig relationships with reciprocal trig relationships. For example, arctangent of x does not equal cotangent of x. If you mix these up, you will not find the correct derivative when working with inverse trig expressions, no matter what. So you have to remember the distinction between reciprocal and inverse trig relationships. Now, we're going to start off by proving one of the inverse trig derivatives, and every other inverse trig derivative can be proved the same way, but we're just going to do one of them. So I'm going to prove that the derivative of arc sine x equals question mark, equals something. So we're going to start with the expression arc sine of x equals y. This is pretty simple, but we don't like the arc sine of x. We don't know what to do with it, so we're going to take it out. We're going to simplify this expression to x equals sine y. Now this is we're much more familiar with this, and this is good because it eliminates the arc sine, and it gives us a ratio to work with. Sine y equals x over 1. Now this ratio is especially useful because we can assume y is an arbitrary angle value, and then we can build a triangle around it based on the information we're given. Sine, you know mnemonic SOHCAHTOA, opposite over hypotenuse. So x over 1, opposite over hypotenuse. Now, we also know Pythag, so if we assign this side as arbitrary value a, we know a squared plus x squared equals 1. A squared equals 1 minus x squared. A equals root 1 minus x squared. So, using Pythag, we can complete this triangle. And then from there, we can find the derivative of this expression. X equals sine y. So the derivative of x is, we're going to find the derivative of this with respect to x. So the derivative of x is 1, which equals cosine y dy over dx. So dy over dx equals 1 over cosine x. Now, cosine y. Sorry. Now, this is very good for us because now that we've constructed the triangle, we can find what cosine y is in relation to x. So cosine y is adjacent over hypotenuse, adjacent over hypotenuse, which is conveniently 1. So this actually cancels out. So you end up with dy over dx is equal to 1 over root 1 minus x squared. Now this means we've actually defined the derivative of arc sine of 1 with respect to x. So we know that the derivative of arc sine of x is equal to 1 over root 1 minus x squared.